Okay, let's get down to it. We're going to get into today the quadratic formula. On the screen right now, you can see that I have the standard form of a quadratic formula written out. There's a couple things I want to point out in this formula. Hopefully don't confuse you. One of those things is going to be that the leading coefficient, that could be positive or negative. I know there's been some things that we've been doing, especially with this quadratic unit, where it's been noted that you want to make sure that the leading coefficient is positive. When you're using the quadratic formula, it really doesn't make a difference whatsoever. Whatever the coefficient is of the x squared term, if it's positive or negative, go ahead and work with it. You might have a b, you might have a constant, but most importantly, the big thing here is that this must be 0. That is huge. So when you get everything into its standard form, you definitely have to have one side of the equation equal to 0. If that is not true, if you don't have that there, if that's not present, then you better get it that way. I haven't even written out the quadratic formula, but you probably know it by now, but maybe not. But the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over. Now everything is over 2a. So not just the square root, not just the negative b, but everything on the top is raised over 2a. Now, one of the things that I would suggest doing, and I think I talked about this in class before we actually started this unit. Maybe I did or I didn't, I can't remember. But one thing that I always suggest to people, especially when you're new to quadratic formula, is that when you're substituting values into the quadratic formula, one thing that's kind of a good thing to do is to put parentheses in place of every letter that you see. Now notice I didn't replace the minus sign that was in front of the b. The negative sign is still there. So I'm just going to rewrite the quadratic formula and put in its place parentheses. And that's kind of how you want to write it out every time. So you want to write it out where you have those parentheses, and notice, there's a few things you might want to notice here. That the squared symbol is outside the parentheses. Also the negative sign there before the b is outside the parentheses. Those are easy to mix up, especially if you're, and I'm going to encourage you guys to use your calculators on this stuff. If you if you do negative 5 squared, you put that in your calculator, you put in negative 5 in parentheses, and then the squared is outside the parentheses, the squared is outside the parentheses, then you'll notice that those are two distinct outcomes. Negative 5 squared is just going to be negative 25. Negative 5 in parentheses squared is going to be positive 25. So there's a big difference there between those two. And I've explained to you why that is the way it is, but you might want to go back and review that. But there's definitely a difference between when you have and when you don't have parentheses. And then that number is either raised to an even power or any power, really. Just you want to kind of pay attention to that. All right, so let's get to our first example here. And let me read the directions here. It says, write your solutions as integers. That just means as positive or negative numbers. Proper or improper fractions are fine. In simplest form, or decimals, rounded to the nearest hundredth. One of the things, I don't know if I've said this before, one of the things that I would say is the most useful thing about the quadratic formula is that I would say it's most useful when your roots are not integers. When they come out to be like these really long, basically I should just say irrational, but when they're these long, non-repetitive decimals that just kind of keep going and just never end. Obviously they don't terminate. If you have an irrational number, so if you end up getting irrational, I would say the quadratic formula is one of your best bets. You can really use quadratic formula with anything, but I'd say it serves its best purpose when you're dealing with non-real answers, when the answers don't come out to be like 5, or they don't come out to be negative 3 exactly. So if you get, you get these non-distinct, these numbers that keep on going and going and going, that's what I'm talking about. Looking at this first example right here, you'll notice that everything is the way we want it to be because we've got the one side of it equal to 0. And that's all that you need. It doesn't matter that the x term is positive or negative. So now what I'm going to do, and you don't have to write this out, but I'm going to write it out. I've got a is equal to 1, b is the coefficient of the x term, 8, and c is the constant, 5. I'm going to go ahead and write out the quadratic formula, but like I said before, I'm just going to write, instead of the letters, I'm going to write the parentheses. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's what I'm going to do. And then I'm going to, in its place, I'm going to put those letters there. B is 8, so I'm going to put an 8 wherever there's a B. I'm going to put a 1 wherever there's an A. We're going to put a 5 in the one spot where there's a C. Now I'm going to go ahead and just start solving this. And if I were you, I would avoid trying to put all this in your calculator at once. There's going to be a point in this problem where you're going to want to put this in your calculator. But right now there's a lot of stuff going on. So let's kind of simplify it as much as we can before we start inserting numbers into our calculator and making this kind of confusing. 8 just becomes negative. I'm going to write plus or minus. Now 8 squared is 64. And I'm going to try to do some of this math here if we can. 4 times 1 times 5 is 20. So I'm going to put minus 20. And I'll put the square root or radical around that. And then 2 times 1 is 2. And then we can simplify this even more. So you got negative 8 plus or minus 44 all over 2. And this is where you might want to use your calculator. I'm going to go to my calculator app. You got negative 8 plus or minus square root of 44 all over 2. So I'm using an app here that identifies my handwriting, but this is exactly what you're going to want to put in your calculator, which is I have negative 8 plus 44. Now, I don't want to really write it out like this. I mean, you can't put this in your calculator. You can't put plus and minus all that stuff in there at once. So what I'm going to do is just kind of do it at once. So negative 8 plus the square root of 44. All right, and then I'm going to hit calculate, which it's going to give me several decimal places there. And I am not going to round it. I'm just going to kind of leave that in my calculator screen. And then what I'm going to do, then I'm going to divide that by the denominator, which is 2. So I'm going to divide by 2. And then there we go. Now the directions say round to the nearest hundredths place. So the hundredths place is the 8. So when I round that, I'm going to get, what is that, 0.68 or 0.69. And since it's next to a 3, that's 4 or less, so we're going to let it rest. So let's leave it as 0.68 or 68 hundredths, or negative 68 hundredths. I should keep that in mind, negative 68 hundredths. So there's one of your solutions. Negative 68 hundredths, and I should put a little approximate symbol here because that is not exact. That's a estimated or a rounded answer. That's not but it's pretty close. All right, now what we're going to do is I'm going to go back to my calculator app and I'm going to do the minus part of it. So I'm going to hit, all right, so I'm going to put in negative 8 minus square root of 44. I'm going to hit calculate, and this is what you should get on your calculator when you're doing it. So I've got negative 14.633249 dot, and there's an ellipsis there after it. And don't, the thing I didn't mention before is don't round it in the middle of doing all the arithmetic here. If you can keep it in your calculator, and what I mean by that is like it's in your calculator, it might go to the edge of your screen, but it's, the approximation for the square root of 44, or negative 8 minus the square root of 44, negative 8 minus the square root of 44 is still in your calculator. I'm going to, like I said, keep that in my calculator, and then we're going to divide that by 2. And so there we have it. So we have negative 7.316624, Okay, so if I round that, that's going to be negative 7.32. Okay, so there's our roots for our solutions. They're both negative. You know, like I think I've said this before too, but just kind of be on the lookout for that. It doesn't always come out to where you have one positive and one negative root. That can definitely happen where you have both negatives or both of them are positive. Those are pretty good approximations, at least to 2 decimal places, for our solutions or our x values, which are also known as roots, and they're also known as zeros. Next example here, you'll notice that it seems like some stuff is missing, and you might also notice that it's not x, it's an m, but don't let that throw you off. It could very well be any letter. It doesn't have to be the letter x. There's an m squared term, but there's no plain m. That's missing. But if you want to use your imagination, there is an m in there. So I can rewrite this as 3m squared plus 0m minus 8, which just gives us a better picture of what the a, the b, and the c are. So the a is 3, the b is 0, and don't let that bother you. It's okay for the b to be 0. It's okay for anything to be 0, really. Actually, it's not really good for the a to be 0, but because that's going to give us a negative denominator. But the c is negative 8. Okay, so I went ahead and I wrote the quadratic formula, but with no, instead of the letters, I wrote just parentheses. So the b is 0, the a is 3, and the c is negative 8. Okay, and like I said before, just try to get this into, into simplest form as much as possible before you start plugging stuff into your calculator. So there's no such thing as negative 0, so that just kind of goes away. 0 squared is just 0. So now what I'm left with is negative 4 times 3 times negative 8. Well, a negative times a negative is a positive. So I know that's going to become positive. So I've got basically 4 times 3, which is 12. 12 times 8, which is 96. Okay, so I'm going to rewrite it. So if I want to write that 0, I guess I could, but I'm going to kind of just forget about it. So I've got 12 times 8 is 96. All over 6. And again, this is one where if you look at it, if you kind of think about this, the number that's underneath the radical, the 96, is not a perfect square number. So you're not going to get one of those really nice, crisp, perfect square numbers or whole numbers or integers when you work that out. So another way to write this, having that 0 there is kind of superfluous. So I'm just going to get rid of that. So I can just write plus or minus square root of 96 all over 6. I put in square root of 96 into my calculator. I got 9.797. I got 9.797958 ... And then if I divide that by 6, hit equal, what do I get? I get that. So I get 1.632 rounded to the nearest tenth, so it looks like it's going to be 1.63. And the 2 is not big enough to make that 3 round up to a 4. So 1.63 is one of the solutions. And I keep forgetting to do this. I'm going to put approximately. And now I'm going to do the negative value of square root of 96. And I know it doesn't make a huge difference here. I'm just going to show you. So negative square root of 96, when I put the negative in front of that, that just makes the same number that we got before, but this time it's negative. All right, and now I'm going to divide that by 6, and it's going to be the same thing, except this time negative. So this time negative 1.63 is what we got. There are the roots, negative 1.63, positive 1.63, and those all check out. Okay, and like I said, those roots aren't these perfect rational numbers. I mean, these are actually irrational because we actually had to round them. I mean, the numbers that we got when we rounded them are rational, but they started out irrational. And irrational numbers don't really have a spot on the number line. Now to our last example here, you will notice that again, this is not in standard form. So we want to get everything over to one side and get one other side of the equation equal to 0. So I'm going to keep the negative 9g squared where it is. I'm going to move the negative 6g over. So make that positive 6g. I'm going to move positive 1 over, make it minus 1, and then set that all equal to 0. And then once that is the way you want it, you have your a, b, and c values. So your a is negative 9, your b is 6, and your c is negative 1. Okay, so I went ahead and I wrote out the quadratic formula and I substituted all the values in for a, b, and c. And I'm just going to go through the process of kind of whittling it down to as few numbers as possible to make it really easy to put in my calculator. The negative 6 just becomes that. 6 squared is 36. 4 times 9 times 1 is 36. And then I have 3 negatives there, so that's going to make negative 36. All over 2 times negative 9, which is negative 18. Keep going here. I've got negative 6 plus or minus the square root of 0 all over negative 18. And keep going here, the square root of 0 is just 0, and there's no such thing as positive or negative 0. 0 is just 0, so I've got negative 6 over negative 18. And then I'm not even going to put that in my calculator. That can just kind of work itself out. 6 over 18, that just turns into positive 6 over positive 18, which reduces to 1/3. This quadratic only had one solution. It has 1/3. That's actually a rational solution. There it is, just 1/3. That's all we got, was positive 1/3. And the reason we got that was because a negative divided by negative is positive. So that does it with the examples here. I would highly suggest, like I said, when you're using your calculator, like this last example, we didn't necessarily need it, but when using your calculator, try to get it down to as simplest of a form as you can, and then start putting stuff in. If you try to put all of this in your calculator, something's going to get messed up. Whenever my students do that, they always tell me like something's weird happening here. So I'm not getting the right answer, and then I'll look at their calculator screen. I'm like, well, you've got kind of a syntax error or something's up with how you typed it in. Like I said, just get it down to as few numbers as possible, and then put it in, and then that's going to make it a lot easier to do that. Okay, so that does it. Let me know if you have any questions, please. That's it. Have a good night.